The next thing is we are going to determine the chloride content in the filtrate. So first thing, I'm going to get a 1 cc sample of the filtrate, as I did before, and put it in the titration dish. Perfect. Now for this chloride determination, we will have to neutralize first. We know that this has a pH which is higher than 8.3. So first thing we are going to do is use phenolphthalein and then neutralize to the phenolphthalein point, which is a pH of 8.3. Eight, 9, 10. So obviously this is alkaline. And we are ready to titrate with sulfuric acid again. Not a titration really, because we are not going to measure the amount of sulfuric acid, but the important thing for us is to reach neutrality, so then the other reagents can do their work. I'm going to go ahead and continue dripping sulfuric until I see that the pink color has disappeared. Now you can see that this is very pink right now. And pink color is gone. Great, now we are ready for the next step. So I'm going to go ahead and get rid of this sulfuric, which I do not need anymore. And I'm going to go ahead and put some other color indicator, which is called potassium chromate. This is the one that has to work in a neutral environment, and therefore we neutralize this. Now the amount I'm going to put is going to be about 5 to 10 drops. Obviously we are getting a yellowish color. Now we are going to titrate with silver nitrate. That's going to precipitate chlorides as silver chloride. And when it disappears, the indicator is going to change color. And actually this is going to be not a yellow solution, but it's going to turn orange. So I'm going to use 0.0282 normal solution of silver nitrate. This has to be handled carefully because it will stain everything, including your skin. And I'm going to use a special pipette for that, which I got here, and count the amount of cc's. I'm going to start with 1 cc and titrate and stir. You can see that every time I drop, there is a color which is indicating that it goes from yellow to orange. Anyway, the good way of telling when you reach the final point is when you see that this is no longer yellow. I guess I can pick up a second one and continue titrating. This is my second cc. I'm dropping here. Still yellow. Still very yellow. Let's go to the third one. Since I do not know the chloride content, I have to start with a silver nitrate solution of a certain concentration that is not neither too concentrated nor too diluted. So it looks like we are doing okay here. And eventually we are going to reach the final point. It's been 3 already. Quickly I'm going to the 4th. And looks like we are getting a color change. This is what I was looking for. Now the yellow color is disappearing and the orange is staying. You can see that very well. And this is my final point. Because of the peculiar concentration of this, I know that every cc of 0.0282 normal silver nitrate is going to be equivalent to 1,000 milligrams per liter of chloride. So in my case, since I have 3.78, actually 3.77, that means that I have exactly 3,770 milligrams per liter of chloride in my filtrate. And this concludes our determination of the chloride concentration in the filtrate. You can see that this is no longer yellow.